What's up, Leetcode? It's your boy Poggers, and today we'll be going through Biweekly contest number 33. So let's get started. First question, thousand separator. Given an integer n, add a dot as a thousand separator and returning to string format. So this question is quite trivial, and I didn't really want to solve it by myself because I know it's such a common problem to want to add separators in a number that I just googled the question, and I pretty much copied the first thing that I saw was this here, formatting, and what this does is add a comma instead of a dot as a thousand separator. So as a quick and dirty solution, I just replaced the comma here by a dot, but for sure you could have divided by 1,000 until the number is equal to 0 and add a dot each time. But whatever works here, I don't think time is really a constraint. Just want to make it work. Now, the first real question. Minimum number of vertices to reach all nodes. So this question was basically find the smallest set of vertices from which all nodes in the graph are reachable for a given directed acyclic graph. So I looked at this question for a while and then I realized one thing. You only need to have the set of all nodes that aren't pointed by any other node. So let's say the source nodes in the graph. So in this example, it would be 0 and 3. Because every other node in the graph are at least pointed by one other node. And there has to be a path from the source nodes to every other node. So in this example, 2 is like pointed by 0 and 4 is pointed by 3. So eventually the source nodes will reach all the nodes. So really the answer just has to be return all the source nodes in the graph. So you can count the incoming edges for every node and then return the set of nodes that have 0 incoming edges and return it as a list like this. And that should be good. Now, minimum number of function calls to make target array. So we're given, well, we're not given, we have an array of zeros at the same length as the target numbers here, and we want to make our zeros equals to none, and we can do two operations as described by this function here. We have our first operation is to increment any index in the array, and the second operation here is to double every element in the array. And we know that doubling is basically the same as bit shifting, so that's where I gained my insight for this problem, that basically we could do things in reverse. We could start from the numbers here, and basically we could look at all the 1 bits, like the first bit on the right for every number, and if it's set, it means that we need to increment that value, or that value was incremented. And afterwards, we can bit shift all the numbers to the right and increment our answers like this. And we keep repeating that process as long as there's at least one number in the nums array that is greater than 0. So it looks like this. So while any number is greater than 0, we iterate over every number. If there's a 1 bit that's set, it means there was an increment, so we have to do the reverse and the increment. And then we bit shift everything to the right. And then we need to remove 1 from the answer because the last bit shift we did was useless because there was no numbers to the left, no bits to the left. So we need to account for that useless bit shift at the end. So we remove 1 like this. And it gives the correct answer. And final question. Given a 2D array of characters grid of size mn, you need to find if there exists any cycle consisting of the same value in grid. A cycle is a path of length 4 or more in the grid that starts and ends at the same cell. Blah 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 blah. So I think the key insight here is that what they mean by a cycle is path length 4 or more, it means you can't really go back from where you came from. Like, the smallest way to make a cycle like this is like to make a cycle where you don't go back on the same path you came from is to do like a square like this that is of size 4. So if we just do a BFS and say that we can go back from where we came from, we can say, okay, so let's add every position we meet in a set of positions, and if we ever encounter a position we already saw, ignoring the position where we came from, then it means there is a possible cycle. So here we iterate over every position. If we never encounter that position, we do a DFS on it, and then we do a regular grid-based DFS. So we get all the neighbors like this, and then we check that it has to be the same letter. And then here is the crucial part, that we say if we ever encountered that position before, then we return true. Otherwise, we keep DFSing on the neighbors. So yeah, the key insight is just passing prev. So let's say you go to the right here, then you'll never go back to the left here. So you don't have to handle that case, because you have seen this, but since you can't go back the way you already came from, the minimum ways to encounter the same position is doing a square path like this of size 4, so it respects the constraint of the problem. Good enough? I hope you enjoyed this. See you tonight on the weekly contest. Bye bye.